Before explaining the mechanism of adsorption, I'll give you two examples of adsorption. Consider oxygen taken in a closed vessel containing powdered charcoal. The pressure of the gas is found to decrease. This is because oxygen gets adsorbed on the surface of the charcoal. Here oxygen is the adsorbate and charcoal is the adsorbent. Another example of adsorption where adsorption takes place is that air contains moisture in it. This moisture present in the air can be removed with the help of silica gel. Silica gel is the adsorbent and moisture is the adsorbate. Now let us see the mechanism of adsorption. Consider the figure given. The surface of adsorbent is shown, and on the surface you can find two adsorbent molecules. In the bulk or the interior, one adsorbent molecule is given. Now consider the adsorbent molecule which is in the interior or in the bulk. If the adsorbent molecule is in the interior, that molecule of adsorbent will be well surrounded by other adsorbent molecules on all its sides, so that there will not be any net force acting on such an adsorbent molecule which is in the bulk or which is in the interior. That is, there is no net force acting on an adsorbent molecule if it is in the interior. But when the adsorbent molecule is at the surface, see the figure, such an adsorbent molecule, if it is at the surface, will not be surrounded by atoms or molecules of its kind on all sides. So such an adsorbent molecule on the surface will possess some unbalanced attractive forces. These residual forces are responsible for attracting the adsorbate particles. When the gas molecules gets adsorbed on the surface of the adsorbent, there will be a decrease of residual forces. That means the surface energy will decrease. Surface energy decreases means the residual forces decreases. So where does that energy go? That energy will be appearing as heat. So during adsorption, energy will be released. Since energy is released, adsorption can be considered as an exothermic process. Now, you know that for an exothermic reaction, delta H is negative. Delta H means it is enthalpy of adsorption. Since during adsorption, heat energy is released, delta H is negative. Now consider Gibbs-Helmholtz equation. You know that according to Gibbs-Helmholtz equation, delta G is equal to delta H minus T into delta S. The sign associated with delta H is negative. As we have discussed just now, we know that adsorption is an exothermic process, so delta H will be negative. Now we have to consider the sign associated with delta S, the change in entropy. Now when the gas molecules gets adsorbed on the surface of an adsorbent, the gas molecules move from a disordered state to a more ordered state. That means there is a decrease in entropy. So the sign associated with delta S will be negative. Now for an adsorption process to be spontaneous, according to Gibbs-Helmholtz equation, you know that delta G should be negative. Now when delta H is negative and when delta H is negative, delta G will be negative. Delta G negative means adsorption process will be spontaneous. Now as adsorption takes place, delta H will become less and less negative and finally it will become equal to T into delta S. When delta H becomes equal to T into delta S, delta G will become 0, and when delta G becomes 0, adsorption reaches equilibrium stage.